Hello class, good morning, welcome, and I'm sure you all had your coffee today because we're going to be talking about the Grand Canyon.
It is a canyon, that is grand. Okay, so we're going to jump into what a canyon is. It is known also as a gorge. Those are vertically formed. They're typically eroded through millions of years through the use of streams or rivers. In our case, it's a river. But it's a valley with very steep cliffs, so don't go near the edge.
That would be pretty bad. Okay, now I'm sure you're all wondering, how did it form? It's actually tectonic plates. So the Pacific and the North American plate collided, and we can see the bottom of the sea found at the top. This is because they both went together, and the bottom went on the top. And so the Grand Canyon specifically is formed because of the Colorado River. So the Colorado River went through and it eroded it down, and that's where we get the steep sides from.
Okay, so fun facts. The length of the river is estimated at about 227 miles, the width at about 18, and the deepest has been recorded thus far is a little over a mile. Ron Blakey called it a scar on the surface of the earth, and I made drawings. This is a real-life fossil you can find at the Grand Canyon. Here's a Pokemon. Same deal.
Okay, so the different rock layers show the different stages that the area has actually gone through. So the Precambrian basement, this is about 1.8 billion years ago, and there's a lot of igneous rock. So what it was is it was volcanic islands formed from a hotspot, kind of like Hawaii, and we see a lot of magma there, and there's not really any fossils because of how hot it was and all of that. Then we have the Bright Angel Shale. This is 515 million years ago. And so this is green in color, and it had a lot of muddy, shallow water at the time, and so we see fossils of things that like to burrow in mud. The Redwall Limestone, this was 340 million years ago. And so what we see here is a lot of limestone, and it's actually red because iron from the other layers stained it. This again, shallow water, murky. The Supai group, this is 300 million years ago. And what we see here is beaches. So there's rapidly changing shores or coastlines because of the rise and fall of the sea levels. And what we notice here is we can tell where the animals were, or not the animals. We can tell where the water was and where the land was because of the different fossils. So on land there's a lot more plants, and in the water we see lots of different animals. The Hermit Shale, this is a broad coastal plain, and there's a lot of meandering streams there. The Coconino Sandstone, this we see deserts, and we can actually look at cross-bedding within it to see where the dunes were. So there's a lot of sand dunes, so think sandstone, stuff like that. And then the Kabob Limestone, this is 270 million years ago. What we see here is, this is when Pangea was. We see limestone. It's one of the youngest layers that we have at the Grand Canyon. And there was a lot of water, again, shallow waters, and we see sponges, sharks, fish. We see a lot of cephalopods as well.
Okay, so we're going to get into fossils. Starting chronologically, we're going to go with stromatolites, which essentially is like bacteria that was within really any water surface, although usually shallow waters. And they were pretty big until predators became a thing in the ocean, and they still exist today, but really only in really remote conditions because you have to have a high salinity content and really shallow water, which doesn't really bode well for a lot of animals now. Secondly, we have trilobites, which are these weird alien-looking bug things from about 525 million years ago. I forgot to mention that these are about 1,200 to about 750 million years ago. And basically, They're funky little bug dudes. But you can see them today in horseshoes. These are crinoids, and it's shown over there. They're like feathery leaf things, and they're kind of like seabirds in like the sense that like they're vicious predators. The most common part of the fossil itself is their stem/spine. Then we have rhizonians, which were basically just structures made by microscopic animals like sponges or coral, but they were passive filter feeders, so they like plankton or like organic matter that was just free floating. They're also known as moss animals because they have these little like arm type dealies that look like moss. Then we have brachiopods, and that is a type of shelled animal. There used to be about like 20,000 different species. Now there's really only about like 300 that exist currently. And they're usually fossilized whole because like the muscles within the actual organism would relax, so it basically close tight. Then we have coral and sponges, which are more familiar. They're both made of small organisms that are basically like singular celled, but then they act like a multicellular organism. But with sponges, they harden and chert basically, and because they're embedded within limestone, and they're a lot harder than limestone, it causes like the nodules to protrude out of the actual rock itself. And we have trace fossils, which are mostly like for land dwelling. You have like giant dragonflies, various animal tracks, and you also have like burrows, some like within the ocean, some not. And there's also remains from the Pleistocene and Holocene era. Basically, there's like sloth bones that are like 11,000 years old in there, as well as Californian condor eggs / bones that are there as well.
All right. Well, class, I hope you took in a lot of information today. I hope you really liked it, and we'll see you next week.
Bye.